I have problem set 10, number 1. Find the value of c for f of x equals 2x squared plus 40x plus c, and to know that f of x has exactly one root. So to start, you know that f of x equals 0 once for the one real root. And for that to become true, f of x must be equal to 0. So you're trying to find the zeros of the equation. So first, use the quadratic formula to find the 0 for f of x. So you'll have x equals negative 40 plus root 1600 minus 8c over 4, and negative 40 minus root 1600 minus 8c over 4. After doing the quadratic formula, which is opposite of b, plus square root b squared minus 4ac over 2a. After that, we want to find the derivative of f of x. So the derivative of f of x is 4x plus 40. And set that equal to 0 to find the x value when f of x is equal to 0. So once you do that and subtract 40 over, you get x equals negative 10. And to find an equation with c in it to set equal to the two 0 functions that we want to have a function with c in it. So you take that negative 10 and plug it into f of x to get an equation with c in it. So you get negative 200 plus c once you plug negative 10 into 2x squared plus 40x plus c. So our next step is to set equal c minus 200 to our two quadratic formulas. And once you do that, it happens over here. You solve down to get all c terms on one side. So I have to multiply by 4 on both sides, square it to get the square root away and everything. Subtract, you'll get two quadratic formulas. And once you're down to those two quadratic formulas, you want to solve the quadratic formula again to find c. And you will get two c values per quadratic formula because it's positive and negative. And then once you have your 4 c values that are all possible, you want to see in your mind or maybe sketch a graph of your f of x and see what c value makes the most sense. So I knew negative wouldn't probably work, and that 459 is a very high value for our equation. So when these two were fair game and you think it's a whole, I tried the whole number first, and then if not, that might work. So 192 is my answer, and that is how you get it.